Let us discuss the machineries and tool required for this practical. Lathe machine. 1. Drilling machine. 1. Bench vise. 1. Drill bits 5 to 12 mm 1 set. Vernier caliper. 1. Steel rule 300 mm 1. File flat 10 inch 1. Let us discuss on fixtures for drilling. A fixture is a production tool used to locate accurately and to hold securely one or more workpieces so that the required machining operations can be performed. A fixture should be securely fastened to the table of the machine upon which the work is done. The main purpose of a fixture is to locate the work quickly and accurately, support it properly, and hold it securely. Common types of fixtures used for the machining operations are 1. Milling fixture. 2. Turning fixture. 3. Grinding fixture. Base plate. The base plate for a milling fixture is provided with tenons at its bottom for proper location of the fixture with the machine table through T-slots. 2 or 4 hold-down slots are provided in the base plate for rigid clamping of the fixture with the machine table. Standard clamps and locators. These are provided for clamping and locating the workpieces with the fixture. As in the case of drill jigs, the clamps used in the fixtures are very rigid and sturdy. The setting blocks. These are used to position the fixture and work relative to the cutter before machining. A feeler is introduced between the cutter and the setting faces of the block for correct positioning of the cutter with the fixture. Balancing weight. This is used dynamically, balancing the irregular workpiece fixed to the turning or cylindrical grinding fixture. In the case of a turning fixture, normally the base plate of the fixture is clamped to the face plate. Vise fixture. Standard machine vices attached with special jaws provide an easy method of holding parts for machining. Other types of tooling used for positioning parts relative to each other for fabricating purposes are also commonly referred to as fixtures. Bending fixtures, assembly fixtures, and welding fixtures are examples of this type. The construction of a fixture depends upon the machining and fabricating methods employed. Classification of fixtures. Fixtures are classified by the type of machine on which they are used. If a fixture is made for a milling machine, it is called a milling fixture. Some of the most commonly used fixtures are turning fixture, milling fixture, welding fixture, boring fixture, assembly fixture, inspection fixtures, etc. The elements of jigs and fixtures are 1. Location, 2. Clamping, 3. Tool guiding or setting, 4. Body base or frame. Types of fixtures. Plate fixture. These are the simplest form of fixtures. It is made from a flat plate which has locator and clamps to locate and hold the part. Angle plate fixture. This fixture is used for machining the part at right angle to the locator. Modified angle plate fixture. This fixture is used for machining the part at angles other than 90 degrees. Vice jaw fixture. This fixture is used for machining small parts. the standard vice jaws are replaced with jaws that are made to suit the work. Indexing fixtures. These fixtures are used for parts that require machining on evenly spaced surfaces. Use of fixtures. A great deal of importance is placed today on improving productivity in manufacturing processes. Application of jigs and fixtures has contributed a lot towards this direction. Fixtures are devices used in manufacturing or assembling. They also facilitate in carrying out special operations accurately. Fixture is a production tool that locates and holds the workpiece. It does not guide the cutting tools, but the tools can be positioned before cutting with the help of setting blocks and feeler gauges, etc. Fixtures of different types are made for 1. Milling, 2. Turning, 3. Grinding, 4. Welding, 5. Assembly, 6. Bending, etc. Let us discuss in practical. Step 1. Make top plate. Step 2. Make hook bolt. Step 3. Make knob. Step 4. Make jig bush. Step 5. Drill jig assembly. Step 6. Remove the top plate from the plate jig. Step 7. Locate component between the hook bolt and touch with stopper pin. Step 8. Clamp the top plate with the knobs. Step 9. Drill diameter of 6x4 numbers. Step 10. Remove the top plate. Step 11. Take out the component from the jig. Step 12. Check the component with a vernier caliper.
In this video, we have discussed the basics of fixtures, their features and type, how to locate a workpiece and a jib, drill the hole on MS channel and check for accuracy. Hi everyone, in this video, we are going to discuss how to mark out angular outlines, file and fit the insert into the gaps.
Objective. At the end of this video, you will be able to 1. Mark an angular outline on part A and B with an accuracy of plus or minus 5 minutes. 2. File part A and B, maintain the accuracy of H7 by G6 for fitting. 3. Fit inserts. Let us discuss the tools and materials required to do these practicals. Vernier height gauge 1. Vernier bevel protector 1. Vernier caliper 1. Steel rule 300 mm 1. Scriber 1. Flat file 12-inch 1. Dot punch 1. Ball peen hammer 250 gram 1. Let us discuss the job sequence for this practical. Step 1. Cut the raw materials as per the dimensions. Step 2. File right angle and mark off part A and B with vernier height gauge and vernier bevel protractor. Step 3. Punch on the marked lines or outlines. Step 4. Remove unwanted materials by hacksawing and chain drilling. Step 5. File part A and B with a linear accuracy of plus or minus 0.02 mm and angular of plus or minus 5 minutes. Step 6. Checking the angular dimensions by vernier bevel protractor. Step 7. Fit part A and B and finish. Safety 1. Do not mark angular dimensions or angle by scale or set square while marking. 2. Do not use hammer for fitting. Let us do the job sequence in practical. Step 1. Select the mild steel flat material to do this job and ensure the selected MS is flat and smooth. Also, ensure that the thickness of the MS flat is 5 mm and the width is 50 mm. Step 2. Place the MS flat on the workbench with the help of the tri-square. Check the outer side of the flat for straightness. If the outer side of the flat is not straight, mark a straight line with the help of the scriber. Step 3. With the help of the vernier scale, measure 72 mm of length on the flat and draw a line using the scriber until the line is visible. Step 4. Now, fix the workpiece on the bench vise and keep it tight using lever so that the vise holds the job tightly. Step 5. With the help of hacksaw frame, cut the flat for 72 mm. Step 6. Now, turn the workpiece facing the excess material on the top of the vise and start filing the surface of the workpiece with the flat file so that the excess material on the surface is removed. Step 7. Now, use a vernier caliper and measure the MS piece for length and breadth, which are 72 and 50 mm respectively. Step 8. Unlock the lever in the bench vise. Set the workpiece between the jaws and begin filing the surface of the workpiece with the flat file. Step 9. The workpiece is taken to a vernier height gauge after filing. Step 10. In order to observe the marking that will be made by the vernier height gauge, chalk is wiped against the workpiece. Step 13. Marking is done as shown in the sketch while holding the workpiece up against the angle block, 5 mm and 18 mm as per the given dimensions. Step 14. With the help of the vernier bevel protractor, mark the angles for 80 and 70 degrees as per the given dimension. Step 15. After doing the marking with a vernier height gauge and vernier bevel protractor, mark the line with the help of a steel ruler and scriber. Step 16. Putting the workpiece on the hand will make small markings along the lines with the help of the dot punch and ball peen hammer, allowing cutting to be done with ease. Step 17. Holding the workpiece at an angle between the bench vise's jaws will allow for straight cutting. Step 18. Cutting is done by hacksaw frame and ensure cutting is not done beyond the punch markings. Step 19. After cutting, you will have two jobs, parts A and B. Step 20. Place the job pieces between the jaws of the bench vise and start filing with the help of the file to smooth the workpiece. Step 21. Both parts A and B are filed. Step 22. Check the alignment by gathering the two workpieces A and B. Step 23. Take a vernier caliper and check for accuracy. Check the dimensions of each and every shape of both part A and part B workpieces. Step 24. Take a vernier bevel protractor and check the angle accuracy 70 and 80 degrees as per the sketch. Step 25. Check for the clearance between the two parts A and B as per the standards of H7 by G6. H7 by G6 fit gives a minimum clearance of 0.007 mm and a maximum clearance of 0.041 mm.
In this video so far, we have discussed how to mark out angular outlines, file and fit the insert into the gaps as per given dimension and sketch, maintaining the accuracy. I hope after watching this video, you will be able to do it practically. Hello everyone. In today's video, we'll discuss the exercises on finished materials such as stainless steel, copper, brass and aluminium, such as marking out, cutting to size, taping, drilling, etc. without damaging the surface of the finished articles.
Objective: at the end of this video, you will be able to 1. Mark on the aluminium, brass, copper with vernier height gauge. 2. Cut extra metal using hacksaw. 3. Drill countersink, counterbore and ream. 4. Tap, finish and deburr. Let us discuss the tools and materials required to do these practicals. Drilling machine 1. Vernier height gauge 1. Vernier caliper 1. Steel rule 300 mm 1. Drill bit 6 mm to 12 mm 1 set. Reamer tool 6 mm 1. Counterbore 6 mm 1. Tap and die set 1. Flat file 12 inches 1. Dot punch 1. Ball peen hammer 250 gram 1. Let us discuss the job sequence for this practical. 1. Check raw material. 2. File to adjacent side and on flat surface. 3. Mark the size of 74 mm by 48 mm outer line. 4. Punch identification mark. 5. Remove the excess material using hacksaw. 6. Mark the center as per dimension. 7. Set the job on drilling machine. 8. Make drill holes as per standard chart. 9. Make reaming, counterboring and tapping. 10. Make countersinking as per dimensions. Let us do in practical. Step 1. Collect the various materials like aluminium, copper and brass that cannot be less than 9 mm thick, 76.5 mm in length and 48 mm in breadth. Step 2. Hold the 3 workpieces against the angle block. Step 3. With the help of a vernier height gauge, mark the lines on the 3 workpieces. Step 4. First, place the workpieces in a vertical position and finish marking as per the dimensions given in the sketch. Step 5. Turn the workpieces horizontally and complete the dimension marking. Step 6. Make the punch marks on the workpieces with the help of the punch center and hammer at the marked junction to make drilling, tapping, etc. as per the sketch, so that cutting can be done easily. Step 7. Also, make punch marks in an extra area if found. Step 8. Unlock the bench vise using the lever. Place the workpiece between the jaws and tighten. Step 9. With the help of the hacksaw frame, cut and remove the extra pieces. Step 10. Do the same in all the 3 workpieces. Step 11. Place the job pieces between the jaws of the bench vise and start filing with the help of the file to smooth the workpiece. Step 12. Complete the filing process for all 3 workpieces. Step 13. Take a vernier scale, measure all workpieces' length, width and thickness and ensure that they are finished as per the given dimensions. Step 14. Fix the drill bit to the appropriate size, 6 mm as per the dimensions in the drilling machine chuck and tighten it. Step 15. Now place the workpiece in the suitable fixture and tighten with the lever in the drilling machine and make drilling. Step 16. In the same way, drilling is made in other workpieces for 6 mm. Step 17. Change the bit to a 12 mm replacement and drill at position B as shown in the sketch. Step 18. Fix the reamer tool in the drilling machine chuck and make a ream at position D for 6 mm as per the sketch. Step 19. Now replace the reamer with a 6 mm counter bore and drill at position A. Step 20. Make counter sunks at positions C and H for 10 and 12.5 mm respectively in all 3 pieces. Step 21. Remove the workpieces from the drilling machine fixtures and fix them between the jaws of the bench vise. Step 22. Now that you have a drilled hole, use the correct tap size for cutting internal threads. To begin tapping, rotate the taper bit clockwise until you feel resistance from the threads cutting into the material. From there, for every full rotation clockwise, make a half rotation counterclockwise. Tappings are done at positions F, E and G for 10 mm, 8 mm and 6 mm respectively as per the given dimensions. Inspect all 3 workpieces after completing the process.
In this video, so far we have discussed marking out, cutting to size, drilling and taping the different materials like stainless steel, copper, brass and aluminum. I hope after watching this video, you can do this practical individually.
Hello students, this video is on the manufacturing process of an adjustable spanner covering the objectives, tools and techniques used. The process involves creating and assembling different parts of the spanner by using equipments such as a lathe machine, drill machine, files, reamers and rivet gun. The video also includes multiple choice questions to test the reader's knowledge of the tools used in the process. So, let us see the world of adjustable spanner production as we uncover the objectives, techniques, and tools behind its creation. Spanner is the most important tool in the precision and craftsmanship. It is an essential tool and staple in every toolbox. At the end of this exercise, you shall be able how to prepare different parts referring to the drawing, prepare for assembly, assemble all the parts and check for the accuracy.
Vernier height gauge. Set of flat and round files. Hacksaw or chain drill. Drilling machine. Reamers. Radius gauge. Deburring tool. Vernier caliper. Lathe machine with necessary accessories. Cutting tools. Die nut. Metal sheet. Hammer. Punch. Bevel protractor. Knurling tool. Tap. Chamfering tool. Rivet gun. Countersink tool. Task 1. Part A, fixed jaw. Check the raw material for the given size. File the surface and side for straightness. File the adjacent side for right angle. Do the marking as per drawing with vernier height gauge. Drill 10 hole for the R5 concave. Remove the excess material by hacksawing or chain drilling. File and check for the dimension as per drawing. Check the radius with radius gauge R5 and R3. Drill the hole 3.8 mm from the side to the depth of 12 mm and reinforce. Deburr and finish smooth surface. Task 2. Part B, sliding jaw. Check the raw material for the given size. File the surface and side for straightness. File the adjacent side for right angle. Mark the job as per the drawing with vernier height gauge. Remove the excess material by hacksawing or chain drilling and fork to hole. File the job for the dimension and check the dimension. File for the radius edges and check with radius gauge. File the edges and deburr the jaw. Task 3. Part C, special screw. Check the rod for 6 by 52 mm. Turn the rod holding in 3 jaw chuck for 4 mm, 10 mm length with H6 finish. Reduce length to 52 mm. Do the threading M6 for the entire length. Check with the die nut for threaded portion. Fixed jaw assembly. Insert the rod into the fixed jaw and position it. Drill 2 mm hole along with the fixed jaw. Fix the cylindrical pin too. Check the dimensions. Task 4. Part D, sliding plate. Check the metal sheet for the dimension. File the sheet metal for straightness and right angle by draw filing. Mark the layout as per drawing and punch. Bend the sheet metal into right angle with the help of 6 mm flat by hammering. Check for the dimension after bending. Mark drill the 4 hole for the slot opening. Chain drilling for the slot opening, remove excess metal. File the slot for the dimensions. Mark drill 4 mm in the position as per drawing. File for 60 degrees angle and check with bevel protractor. Do the radius filing and remove the burrs part knurled nut. Check the raw material as per the drawing size. Hold the rod in the 3-jaw chuck. Turn the round for 1 to mm. Knurl the outer surface with knurling tool up to 15 mm length. Drill 5 mm and tap the drilled hole by M6 tap. Chamfer the side to by 45 degrees. Do the parting off and chamfer the other side. Task 5. Spanner assembly. Check material size for all the parts. File, mark and finish parts A and B to size. Bend part D as per drawing. Remove excess metal and finish to size. File and finish square slot. Do countersinking for all drilling holes. Do turning, drilling, tapping, knurling and parting off the part E as per blueprint. Step turning, cutting external thread and parting off the part C as per blueprint. Assemble part C and A. Rivet and join part B and D. Assemble all the parts together as shown in the assembly drawing.
In this recap video, we will take a closer look at the objectives, techniques, machines and tools involved in this adjustable spanner. In this manufacturing process of the adjustable spanner, we learned about the objectives, techniques and tools involved. We explored the step-by-step creation of different parts, including the fixed and sliding jaws, special screw, sliding plate and knurled nut. The assembly process was also covered, highlighting the use of rivets and screws. Finally, we tested our knowledge with multiple choice questions, reinforcing our skills and understand the tools used in the precise craftsmanship. So, the topic emphasizes the steps involved in making an adjustable spanner. We explored the step-by-step creation of different parts, including the fixed and sliding jaws, special screw, sliding plate and knurled nut. The assembly process was also covered, highlighting the use of rivets and screws. Lastly, we tested our knowledge with multiple choice questions, reinforcing our skills and understand the tools used in this precise craftsmanship.
Hello everyone. In today's video, we are going to learn how to dismantle and mount the pulley.
Objectives. At the end of this video, you will be able to 1. Extract pulley using puller. 2. Extract pulley using arbor press. 3. Mount pulley on shaft. Let us discuss the tools required to do these practicals. Pulley puller 3 legs 12 inches 1. Double-ended spanner set 6 to 32 mm 1 set. Arbor press 1 ton 1. Mandrel 1. Allen key set 1. Soft hammer 1. Let us do in practical. Task 1. Extract pulley from shaft. Task 1A. Remove pulley using puller. Task 1B. Remove pulley using arbor press. Extract pulley using puller. Step 1. Select correct size of puller depending upon the size of the shaft and pulley. Step 2. Apply few drops of oil around the shaft before removing. Step 3. Place the legs of the puller diagonally opposite sides of the pulley to hold the pulley firmly. Step 4. Position the center screw of the puller by hand screwing so that sufficient center screw length is available for complete removal of the pulley from the shaft. Step 5. Tighten the center screw gradually using correct size spanner. And check whether the pulley is coming out freely from the shaft. If not, slightly hammer on the head of the center screw. This will cause the pulley to come out from the shaft freely. Step 6. Clean end of the shaft using flat file to remove any burrs or bulging on the end of the shaft. For removing pulley from smaller shaft, use arbor press. For removing pulley from longer shaft or from the shaft attached to the machine, use proper puller. Extract pulley using arbor press. Step 1. Clean the end of the shaft with flat file to remove any burrs or bulging from the end of the shaft. Step 2. Set the arbor press according to the shaft. It should be less than the diameter of the shaft. Step 3. Select the mandrel according to the shaft. It should be less than the diameter of the shaft. Step 4. Select a pair of parallel blocks and position them on the bed of the press. Step 5. Place the pulley with shaft on the parallel blocks such that the shaft in the pulley is in line with the ram of the press. Ensure that the parallel blocks are as close to the shaft to give maximum support. Step 6. Apply a few drops of oil around the shaft to reduce friction during removal. Step 7. Position the mandrel on the shaft and position the ram of the press on the mandrel. Step 8. Apply light pressure with the ram on the mandrel gradually so that the shaft is extracted out of the pulley. Apply same pressure on the ram till the shaft is completely ejected out from the pulley. Step 9. Bring back the ram to its original position gradually and remove the mandrel. Task 2. Assemble pulley and shaft. Step 1. Deburr the keyway in the shaft and the hub and clean the keyways. Step 2. Check the dimensions of the shaft and the hub and the keyways. Step 3. Check by inserting the hub on the shaft so that it is a tight push fit with the hands onto the shaft. Polish the shaft or scrap bore of the workpiece until this fit is obtained. Step 4. Select a gib head key of the correct section and length. Step 5. Check the key for width by inserting into the keyway of the shaft. File the key until it is a light tap fit in the keyway. Similarly, check the key in the keyway of the hub. Step 6. Fit the hub onto the shaft by tapping slightly with a soft hammer. Step 7. Tap the key into the keyway. Remove the key and check for any high spots and file the high spots. Repeat the above operation until the key head is approximately 15 mm away from the boss of the hub. Step 8. Remove the key and check the fit on the faces. Step 9. Fit key with a firm blow with a hammer.
In this video, we have discussed extract the pulley from the shaft and assemble the pulley and shaft. Thank you for watching and have a good day.
Welcome to today's session on dismantling of gears. Gears are integral components of various mechanical systems serving the purpose of transmitting motion and power between rotating shafts. However, there are instances when gears need to be dismantled either for repair, maintenance or replacement purposes. Dismantling of gears requires a systematic approach and careful handling to ensure their safe removal and subsequent reassembly. In this session, we will explore the essential steps involved in dismounting gears. Let's get ready to go into this topic and discover the key techniques and considerations for dismounting gears. In this session on dismantling of gears, our objectives are: dismantle gearbox from the machine, check out how to replace and repair the worn out or damaged parts. By the end of this session, you will have the knowledge and skills required to dismount gears effectively. These objectives will equip you with the valuable insights into gear maintenance, enhancing the performance and longevity of mechanical systems. Socket wrench set, torque wrench, gear puller, bearing puller, hammer, punch, screwdriver, wrench, pliers, wire brush, cleaning solvent, safety glasses, and gloves.
Dismantling the gearbox. Switch off the main power supply. Inspect the shaping machine gearbox. Dismantle the guard and belts. Support the gearbox with wooden blanks. Unscrew the fasteners by using suitable tools. Remove the gearbox and keep it on the work table. Remove the driven pulley from the driver shaft using puller. Remove the key from the drive shaft. Remove bearing covers and internal circlips. Dismantle the driver shaft by using any soft material like copper rod, aluminum rod, mud wooden block with hammer. Remove the bearings and sliding gear unit from the gearbox by disconnecting spring-loaded shifting lever. Remove the end nut, bearing covers, circlips and grub screws in the spacer of the driven shaft. Remove the driven shaft by using copper rod and hammer, then take out the gears, spacers from the gearbox. Thoroughly clean all the parts using kerosene and wiped out with cotton cloth. Check all the part for wear and tear.
In this session, we discuss the process of dismounting, repairing damaged gears, mounting and checking for workability. Here is a short recap of the key points covered. Dismounting. To begin the process, ensure the equipment is turned off and safely secured. Remove any covers or guards obstructing gear access. Use appropriate tools to loosen and remove bolts or nuts securing the gear. Carefully slide the gear off the shaft using a gear puller if necessary. Inspect the gear for damage such as chipped teeth or crack. Thank you for joining us in today's session on dismantling of gears. We have covered the essential steps, tools and precautions required for these tasks. Remember to prioritize safety, follow manufacturer guidelines and perform regular maintenance to keep your gears in optimal condition. In the next topic, we will discuss the repair of damaged gear mounting and checking for workability. We hope you find this session informative and valuable. Stay tuned for more insightful sessions. Have a great day. Welcome to today's session on repairing of damaged gears, mounting and checking for workability. In last session, we learned how to dismantle gears. Now we will discuss repairing any damaged gear, mounting them correctly and checking their workability. Repairing damaged gears requires a meticulous approach as even minor deviations can affect their performance and longevity. Let's dive into the intricacies of gear repair, empowering you to tackle gear damage effectively and restore your mechanical systems to their optimal working condition. In this session on repairing damaged gears, mounting and checking for workability, our objectives are: repair gear tooth by dovetail method, repair gear tooth by stud and welding method, assemble the gearbox, mount the gearbox to the machine for the test run. By the end of this session, you will have the knowledge and skills required to repair, mounting and check the workability of gears effectively. These objectives will equip you with valuable insights into gear maintenance, enhancing the performance and longevity of mechanical systems.
Repair broken gear tooth, dovetail blank method. Support the gear against a V-block and clamp it by parallel clamp. Mark the dovetail groove on the gear wheel from both sides using a vernier height gauge and vernier bevel protractor. Punch the marking lines. Drill 3 mm there. Relief holes 1 each on the corner of the dovetail. Remove material from the gear to shape and size of dovetail as per marking. File the blank to the profile of the gear tooth as per punch mark. File the dovetail portion of the blank. Fit the blank into the dovetail groove of the gear wheel. If necessary, file the blank till it fits in. Apply Prussian blue on the dovetail groove to check the high spots in the blank piece. Remove the high spots and make a snug fit in the dovetail groove. Drill 3 mm diameter. 2 holes up to a depth of 33 mm on the blank and gear wheel in assembled condition. Reaming the holes using a hand reamer. Dismantle the assembly and remove the chips from the holes of the gear and the blank. Assemble again and fit the dowel pins in the holes by a slight tapping. File the profile of the gear tooth to the correct shape. Use a template to check the profile. File the sides of the blank, flush with the gear. Repair broken gear tooth, welding method. File the broken tooth surface become flat. Mark for 2 holes on the surface with 10 mm center distance between the holes. Punch the centers for drill holes. Drill 5 mm diameter. Holes on the centers to a depth of 9 mm. Tap the holes using AM6 hand tap. Remove the chips and clean the tapped holes. Fix up 4 hexagonal-headed M6 bolts into the tapped holes and tighten them securely. Cut off the hexagonal head of the bolts by hacksawing. Build up material by welding just enough to make the tooth profile by filing. File the built-up material to tooth profile. Use a template frequently to check the profile to have correct shape and pitch. Mounting and check for workability. Clean the parts before assemble. Fill up the lubricating oil into the gearbox up to the indicated level. Mount the gearbox with the machine. Check the test run with different speeds, 4 speed.
In this session, we discuss the process of dismounting, repairing damaged gears, mounting and checking for workability. Here's a short recap of the key points covered. Repairing damaged gears. Inspect the gear for damage such as chipped teeth or cracks. Minor damage can be repaired by smoothing the edges or repairing the teeth using a file or grinding wheel. For severe damage, consider replacing the gear with a new one that matches him specifications of the original gear. Mounting and check for workability. Clean the shaft and gear mating surfaces thoroughly using a cleaning solvent or degreaser. Apply a thin layer of lubricant or gear oil to the shaft and gear mating surfaces. Carefully slide the gear onto the shaft, aligning it properly if applicable. Use a torque wrench to tighten the bolts or nuts according to the manufacturer's specification. Reinstall any covers or guards that were previously removed. Check the test run with different speeds. We appreciate your participation in this session today on repairing damaged gears, mounting and checking for workability. The crucial procedures, equipment and safety measures needed for these duties have all been discussed. To keep your gears in top shape, keep safety first, adhere to manufacturer instructions and do routine maintenance. We hope you learned something from and found value in this lecture. Watch this space for more illuminating discussions. Enjoy your day.
It's all about fair play. Beyond passion, commitment, and hard work, there are deeper values like honesty and integrity associated with sports. Doping is fundamentally against this spirit. Guided by the powerful mission of promoting doping-free sports, the National